So sometimes we're asked to find how many x-intercepts there are when we're graphing things. And we don't want to do a whole bunch of work to figure that out because you can actually do it pretty quickly. So if we have our kind of our normal graph here, y is equal to x squared, we're going to have an axis, we're going to have our parabola looking like this-ish with our vertex right there. So right there, you're not going to have any x-intercepts, okay? So none. Now what about this one? Y is equal to negative x squared plus 3. Now what I'm doing basically is just really quickly sketching these because you can figure out where the vertex is going to be based on what P and Q are. So this one, we're going to have 3 as Q. So it's going to be up here, and we can see that A is negative, so it's going to be doing something like that. Okay? So then we can see that there's 2 x-intercepts. What about this one? Y is equal to x squared minus 2. So if we have this one, we're going to draw something like this. So if our Q is negative 2, we're going to have the vertex down here, then it's going to open upward. So then we're going to have 2 x-intercepts. So basically all I'm doing is looking at these and saying, okay, well there's no P, so then it's the vertex value for the x is just going to be 0. And then our Q is negative 2, so it's going to be 0, negative 2 for the vertex. Then I just look at to see what the sign of A is. And if there's no A, the sign is just positive, so it's opening upward. Same thing here, I just looked and saw, okay, there's no Q, there's no P, so it's going to be 0, 3. As the vertex, A is negative, so it's going to be opening downward, so then we're going to have 2. And then if you just have, if it's the vertex is just at 0, 0, you don't have any x-intercepts. And that's just kind of how you do it. So you could do this for any formula at all, and you could just figure out, just really quickly with a little sketch, how many x-intercepts you're going to have. So the question is, determine a quadratic function in vertex form for the following graph. So we're just given a graph of a function, and we're expected to find the formula. And it's actually fairly simple. So we just can say f of x is equal to ax minus p squared plus q. Okay, that's the basic vertex form. And remember, f of x is just kind of the same thing as y. So we're not too concerned about that. So all we need to do is say, okay, let's look at the vertex first. So the vertex, the point for the vertex is 5, negative 4. It's just this point right here. And all we can do is we can just sub in the 5 for P and the negative 4 for Q. So we're going to say f of x is equal to a times x minus 5 squared minus 4. Now, all that we need to do basically is find A, and we'll have it in vertex form. So all we need to do is find another point on the graph that's a perfect point. So they've nicely outlined one for us here. It's at 2, negative 1. And we're going to use that point to find A. So all we're going to do is sub in the value of 2 into x and negative 1 for f of x. So we're going to say negative 1 is equal to A times 2 minus 5 squared minus 4. And all we have to do is solve for A. So going back to the start, all we did was sub in the vertex, sub in a different point for y and for x, and then we can actually just solve for A. So if we have negative 1 is equal to A, and 2 minus 5 is negative 3 squared minus 4. Let's move the 4 to the other side. So we end up with 3 is equal to A, and negative 3 squared is just 9. A times 9. So if we divide by 9, we get A is equal to 1/3. So then our final formula is just going to be f of x is equal to 1/3 x minus 5 squared minus 4. And that's our final answer. So that's all you need to do is sub in the vertex for P and Q. So it's basically just doing the opposite of what we did last lesson. And then all we have to do is sub in another point for y and for x. And then we just solve for a.